Okay, we are actually live now. Welcome everyone to ACDE 155. Um, Bunch of things today. We'll cover some Shanghai stuff, and I think Maris, you have some testing updates from there. Then Cancun, we had a bunch of discussions about zero blob transactions in the 4844 call this week, and I think it made sense for some of those to be bubbled up here, so we can hopefully move forward on them. And then there were a few other Cancun related topics. One regarding minimal presets on the beacon chain, which EL clients, I believe, need to start caring about with Cancun because of the engine API changes. We also had a breakout about SSZ transaction format, so we can sort of recap what happened there in the next steps. And then there was another SSZ EIP about the withdrawal routes. And then finally, something regarding the transaction pool API. Um, so I guess to start on Shanghai, so we have Sepolia planned for February 28th. Ideally, we'd announce that early next week. And that's assumed client put releases out for it. That said, yeah, I know Marius, you ran into some issues when testing on the latest testnet. Do you want to maybe give us a quick overview of what happened?
Yes. So full nodes were not, full synced nodes were not able to correctly sync to the Shanghai testnet. I'm horribly butchering this, so I'm just going to paper over it. Basically, the issue is if we got a block that was empty, so it had no transactions, no uncles, and no withdrawals, then we would actually set the withdrawal hash to nil instead of empty withdrawal. Sorry, not the withdrawal hash, the withdrawals, and we wouldn't download we wouldn't download the block because the block is we wouldn't download the block body because the block body is empty, and we would but we also wouldn't correctly initialize it. This problem, we had a similar problem in the past already. The thing is, we can only figure out these issues if we have empty blocks, and so fully empty blocks, they don't need anything to be downloaded, and we are full syncing, so it doesn't happen on snap sync. It doesn't happen when you're not syncing, when you're following the chain. So yeah, it's kind of a weird edge case, but given that we had already two issues there with Geth, it might make sense to have this as a test, as a sync test, just syncing a full chain, full syncing a chain from another client that has fully empty blocks. And yeah, it's fixed now. It's not in the release, but we're planning to do another release with this fix and another fix, basically today or soon. And yeah, so people on Sepolia can just use the normal version, but if you want to sync up after the fork happened, then you should use current master. That's basically it.
Thanks. I guess I'd be curious, are we aware of other client teams having this issue?
So I haven't noticed any issue during the sync. but I will recheck all the edge cases. Would be nice to have Hive test, of course. Yeah.
Anyone else?
So these issues arise because of one optimization that we do. If a block has no body, we're not requesting the block body because we know from looking at the header that the body is empty, and so we're not asking the network for it. I'm not sure if other clients have the same optimization, but yeah.
Yeah, we might have this optimization. We probably do have it in Aragon, so I need to double check our code and see whether we suffer from the same issue or not.
Okay. Mikhail?
Yeah, a quick comment on not having a body for empty block is we have these get payload bodies methods in Engine API. So just to be sure that those are handled correctly, even if body is empty, you're not storing it.
Yes, those are handled correctly, and we have tests for it. So yeah, this is not a problem. It's really only during sync, and also like if someone like gives us a malformed block, either via now also via the ETH protocol, but before that via the Engine API, we would just reject it. But now we also reject it on if someone gives us a malformed block on the ETH protocol.
Okay, and Mario in the chat said he can add a Hive test for this. So we currently had the Hive tests for both empty, like blocks without transactions, blocks without withdrawals, but not the combination of fully empty blocks. I guess I'm curious just to hear from teams. Do you feel this should change sort of the timeline for Sepolia, or given we already have a fix in Geth, and you know, it seems like it's a pretty easy edge case to describe. Our client's still confident in having a release for Sepolia, or at least, pointing to master for this bug fix in the coming days.
This is Basu. I think we'd be more comfortable with that second option there. We're planning our release for Monday.
Okay, and the Monday release would make sure to not have this issue. Is that right?
Well, we'll try to get it in there, but if we're open to the option of someone doing a build off of main instead, that would make us a little bit more confident that we can sort it out.
Okay. Sounds good. Any other client?
Yeah, I think we can do a release early next week.
Okay.
Yeah, the same.
Okay. Perfect. So what I'll do is I'll follow up with all the EL teams offline and see whether they have a release or recommend pointing to master branch and we can use that for Sepolia. But I guess, does anyone feel like we should delay Sepolia over this? Okay, so yeah, guess we're still on track for February 28th. And if you're listening, you should expect releases from the various client teams or at the various master branch commits that support Sepolia in the next few days. Anything else regarding Shanghai Capella that people wanted to discuss? Oh, Barnabas, yes.
Yes, I could give an update regarding the Withdrawal Devnet 7 that we have just launched on Tuesday.
Yes,
So
please.
this Devnet 7 was basically a very heavy stress test, and they meant to test for the worst case scenario on the mainnet. What we did is a 600,000 validator set with 360,000 BLS key change happening during Chapella, with deposits and withdrawals happening all at the same time with field queues. And Chapella was this morning at 9 a.m. UTC, and we saw a huge fluctuation in CPU and RAM usage during the fork transition, which was expected due to the extremely high number of BLS messages gossiped in the network. Within a few days, we will see exactly how many messages have been lost, or get a better estimation. And what we also noticed is we realized that there was a bug in Bezu and Prism where this pair did not discover new deposits. And we haven't noticed this issue before because we didn't make this amount of deposits in other networks. But maybe someone from Bezu can explain this bug a bit better.
And is the issue they could not see when they were overwhelmed with deposits? They missed a large share of them, or they stopped processing them altogether?
So they stopped processing all, and also there were some blocks missed, block proposals missed, and we figured that it was possibly due to some RPC batch size issue.
Got it. Anyone on the Besu or Prism team have more context?
I'm not aware of this issue, so that I will follow up right now.
Yeah, I can. This is Matt. I can provide some more context. We recently limited this RPC method intentionally to a small value to kind of avoid some DOS vectors stuff. But we realized that, in the case of Prism, they expect around a batch size of 1,000. So, we're providing a much smaller batch size. I'm not sure why it would completely stop the process. We need to probably investigate that, but we will reevaluate this value. And we're aware of the issue specifically.
Got it. Thanks. Anything else on Chapella?
So in conclusion, basically, we have lost one epoch. We went down to 62% during fork transition due to the extremely high RAM and CPU usage, but we recovered within 3 epochs afterwards. And I think it's expected to have a lot smaller case on the mainnet because we don't expect this amount of BLS ghost happening, and we're going to have a lot more nodes. So this is really just the worst case scenario.
And then what was the split of the different validator combos on the Devnet? Was it like matching mainnet, or was it like an equal split?
It's not equal, and it also doesn't match. I can get you the number.
Sure. Yeah, if you want to post it in the chat if you don't have it off the top of your head, yeah, that'd be great.
And will we run the MevBoost circuit breaker test on this testnet as well?
No, we'd be running that on mainnet Shadow Fork 2.
Okay, cool. That's still in progress though?
Yeah, I had some issues syncing up the nodes before starting the Shadow Fork, so it's a bit delayed, but we get to that soon. And MevBoost has been deployed on Shanghai as well. But I think for now, it's just returning 204 as builders are coming online, but the relay is set up. So we could do a circuit breaker test on Shanghai as well, but I think the idea is that we don't because we want to keep it stable for public testing.
Yeah, that's fine. Thanks.
Barry, which version are you running for these tests?
Of MevBoost? Or
no, CL client.
At the moment, it's the latest releases. So it's still waiting for the relays to come online before I go asking around for which versions to update them.
Okay, so you were not planning to use the upcoming CL release?
I will once the releases are done, but we haven't
Okay.
started the shadow fork yet. So once it's done, then I would reach out to get the latest images to run there.
Cool, thanks.
Yeah.
Okay. Anything else on Chapella?
I want to say that I just confirmed that we already handled this empty body issue correctly in Nethermind.
Nice. Okay, and yeah, for people listening, so expect a blog post early mid next week with this, and also keep an eye on the different client repos as they put out releases or announcements for their Sepolia Chapella versions. And again, this fork is scheduled for February 28th, which is Tuesday, about 10-ish days from now. Yeah. Anything else? Okay. Otherwise, let's move on to Cancun. So we had a 4844 call this week, and I think one of the big, things to agree on to move forward is what to do with zero blob transactions. So there were a bunch of mempool designs that relied on the ability to discriminate between blob and non-blob transactions. And an assumption there is that the sort of EIP 4844 type 5 transactions have blobs and therefore are bigger, and the other ones don't. And so there was discussions about whether we should allow zero blobs transaction in protocol, but ban them from the mempool so that if blocks are created with them, it's fine, but clients don't process them in the mempool directly, whether we should just straight up ban them in protocol as well, at least to start. And if we do allow these zero blob transactions, then what's the right way to discriminate, between blob and blobless transactions? Do we want to look at basically the length of the blob list, at the transaction type? Do we want to gossip this information in something like EAT68? And basically, I think aligning on all of this allows us to get to a transaction pool design, which hopefully is more efficient and can handle the actual blobs in a way that's different from transactions that don't have any blobs. So I don't know if anyone, I guess from the EL side, wants to maybe start and chime in here. My feeling is most of the EL folks were leaning on the not allowing zero blobs, but different sort of variations of that. Yeah, Lucas?
So I was thinking about this quite a lot, and while I settled out that I don't like any solution, but what I'm leaning to now is either having some additional metadata for transaction, for example, transmitted in through ETH68, or just using the size of transaction to determine the rules of how we behave with this transaction. So for example, if we have a big size transaction, even if it's like whatever, if it's a blob transaction or not, it will go into this large transaction pool, right? And this also resembles to me a bit how, for example, some managed languages like .NET or Java handle big objects that for garbage collection. They have separate object heap for that with special rules. So it kind of makes sense for me, and it's like it is the elegant solution from the design perspective. And from implementation perspective, like trying to think about that it's not about type of transaction, but the size of transaction also makes some sense to me. So I'm not entirely convinced. Like I said, I don't like any of them. All of those things kind of like creep issues into implementation and make it more complex, but maybe that's what I would suggest.
Got it. Okay,
Yeah,
Peter, why do you disagree?
I think it's a horrible idea.
Okay.
The theory is super nice, super elegant, and insanely complicated. So the fact is, in order to differentiate, so the whole point of block transactions is that you have behavioral limits on it. It simply behaves completely differently than large transactions. You can have a lot of large transactions in a block, but you can only have 1 or 2 block transactions in a block. That's a huge behavioral differentiation. And if all of a sudden I can have 0 block transactions and it's gone, hacking E68 to transmit the block size or the transaction size, that's completely moot because I still can have really huge, I can have a 2 megabyte transaction, plain transaction that would be transmitted through one mechanism, and block transactions would be smaller. And I think it's just the whole point is with block transactions is that something very, very specific that we can use those specifics to make optimizations. And I get it that from a research perspective, it's super nice to make everything completely generic, and then the whole thing will go to fall apart just like the Merkle-Patricia try falls apart. It's a piece of shit. And the same thing will happen with transactions. We just make this meta transaction, and then we'll just say, okay, screw it. We sure hope that MEV boost and all the others can handle it because clients sure as hell won't be able to. And you're just delegating everything out to somebody else who has the infrastructure to handle all that crap.
I didn't get your argument there. You said like you can have a 2 megabyte bit transaction and a block transaction, and what's the problem there?
My point is that I cannot differentiate it. So currently the idea was that block transactions, we transmit the transaction ID in the transaction announcements on networks, so I know which ones are block transactions and which ones are not. The new suggestion was to forget that and just transmit the size, but then I just get one big soup of transactions again.
Right, but how? Like, I still don't understand
the problem by the way, Lucas. Only the transaction IDs in E68.
Alexei, you had your hand up.
Yep, thanks. Another idea would be to encapsulate all this separate logic for handling big transactions or block transactions or whatever, because it's just 1 or 2 cases. Maybe we will have more in the future, and we can announce not size or type of transaction, or we can just share a flag that says you would not like to download this transaction or like that. I mean, transactions will be, well, different. I mean, if you will load a transaction and the size is not is not passed, the correct size is not passed, you will verify it that it is too big, and you reject this peer. Probably you want it. You want to reject peers that send you big block transactions or just big transactions at the end. And so instead of sending some details about the transaction, we can just send like enumeration that says it is a big transaction, that's why you don't want to load it, or it is block transaction, and so on, and add more reasons why you should not download it. And it can be like the solution.
Got it. Andrew?
I think for simplicity's sake, I agree with Peter. I think the simplest thing to do is just to introduce a new transaction type for the non-blob SSZ transactions. And it already chimes in nicely with IS-68. It has nice semantics. I think like for total simplicity, to my mind, is the best solution. I don't actually see what are the drawbacks.
And the reason for adding this extra type of transaction is so that you can only using like SSZ supporting infrastructure sign both blob and non-blob transactions. Is that right?
Well, and going forward, I mean, I think going forward we want to move to SSZ, but so the new type SSZ without blobs will probably be our preferred transaction type for not only for L2 solutions, but potentially for everything. And this like clear differentiation between non-blob transactions and blob transactions by their type, I think it plays nicely with the semantics because you kind of they serve different purposes. Rather like a B as your run-of-the-mill transaction or or carry blobs. So I don't see a problem with two types. I think it's a benefit that it just highlights the semantical difference.
Yeah, but and so so this means that we'd have like effectively 5 transaction types, right? Like, or maybe 6 with the pre-EIP 151 or whatever. But you would keep the existing legacy transaction types, introduce blob transaction, and then blob transactions which require a blob, and we can have this hard limit there, and also kind of separately introduced an SSZ zero blob transaction. And this means that, like Maris is saying in the chat, we can do things like add more restrictions to blob transactions, like for example, not having access lists, not allowing contract creation, and so on.
Right. Yeah, that makes sense.
And I guess, with regards to the transaction pool, we don't actually need all the clients to have the exact same implementation. Like this is not the case today. So say we went down this route of having 2 new transaction types, one that is like both of them being SSZ transaction types, one of them being a blob transaction, which requires having a blob and potentially has some other restrictions. And then another that is SSZ no blob transaction, which is effectively the equivalent of like a type 2 transaction today. How did people feel about that? Lucas?
So while we don't have to have the same transaction pool implementation, historically, I've seen that we converge on the very similar implementations due to security reasons. And second thing, we still need to agree on ETH68 how it should look like, because this is what we all need to be support.
Right, that makes sense. Yeah. Danny?
I was gonna say there's gonna have to be conditional logic somewhere around number of blobs, around size of transactions, etc. And I think ultimately, if engineers think that is embedded in the type is going to reduce complexity, then that's probably just what we should do, and move forward with that.
Lucas?
The one good argument that I heard about allowing zero blob transactions is that if we want to upgrade our transactions to, I don't know, have a new field, and this new field will be for blob and not blob transactions, then we have to create two transactions, right? And this kind of complexity might increase if we like introduce something else that will have a separate transaction type. So this kind of is some kind of metadata. If this transaction has blobs or not, it doesn't have to be a transaction type. But yeah, we need to have this logic somewhere. So I agree, but not sure if the transaction type is the best thing. I was thinking about thinking about transaction type as like some of its last bits as flags, for example. But then we only reserved 127 transaction types, which is a bit not enough. So for example, if it was like 32-bit, if the last bit is set, then it has blobs. If it's not set, it doesn't have blobs, etc. But we can probably either just do the duplication, right? So in this case, or have a separate metadata field with some flags. But yeah, that's it.
So one thing that I kind of wanted to add is that we very, very often fall into that I don't know, fault, error, whatever. We try to make things super insanely generic from the get-go, and we have absolutely no idea why. And from my perspective, that feels like a bad thing to do. For example, saying that, well, we shouldn't introduce specialized transactions because we're going to run out of 128 transactions. I mean, that's a very, very big, a very strong argument. So I mean, we have absolutely no idea if we will ever introduce another transaction or transaction with another field. So I mean, in my opinion, I personally prefer to go with the simplest solutions and try to figure out or try to make it more generic or when there's actually a genuine need for it. And yeah, that does mean that it might happen that in the future, currently we make a decision that's not the best in the future, and in the future will go in a bit of complexity. But the problem is that if we make it super generic just for reasons, and then we have to tiptoe around that forever, and there will never be actually another field ever added, it just feels weird. Also, this kind of ties into what Marius' suggestion was, that he suggested that we could even cut down more features onto the block transactions. And I don't know, personally, I prefer to have transactions that have very, very dedicated use cases. So this whole 4844 has a very, very strong design, a very, very strong use case. And in my opinion, we should try to just focus on that use case and not make it this superset of everything. I mean, for sure, it's elegant to make it a superset of everything, but is there any legitimate reason to do so? Because currently, apart from saying that it's elegant from a theoretical perspective, there's no reason whatsoever that anybody could come up with.
So, trying to think what's like the best way forward here. It does feel like, I don't know, from the EL side, like having this be like, yeah, having this be more tailored around the current use case seems like it's simpler. There's like some value both in terms of like making a generic framework and yeah, and also like ease of use for like L2s if we allow zero blob transactions, but it seems kind of marginal. So yeah, I guess, you know, does anyone on the EL side feel like we should like push forward for like a zero blob and sort of more flexible 4844 transaction type? Otherwise, we could at least make the call that like the zero blob transactions shouldn't like be possible. And then, you know, there's this whole other SSD discussion about how we want to approach that. We can go to that after. But I think if we all agree that like we shouldn't do zero blob transactions, I think the other thing, the other thing to figure out is like, do you ban those in the mempool only, or do you ban them in protocol as well? And Dano has a question about like what wallets and chain infrastructure tooling projects thinks. I don't have a great view. Does anyone on the call have one?
I would suspect this is currently a very domain-specific debate that most people don't have a perspective on.
And I think the optimism folks seem to like think this was fine. And generally on the L2 side, my feeling is that whatever gets 4844 shipped the quickest, assuming it, you know, is like a small technical change, like they would probably prefer to work around that and have 4844 a month earlier than you know, have 4844 be delayed because because we're not sort of aligned on the transaction types. And yeah, Alexei has a comment in the chat as well. Like, you know, there's also a world where, like, say we just ship this and only L2s use this, and we sort of don't have the whole SSZ move happen in Shanghai. So that, sorry, in Cancun. So that's possible as well. And if you went down that route, it's basically only L2s that have to deal with this new SSZ transaction type. Maybe it's very limited, and then maybe, you know, in the fork after we can like come up with a broader SSZ scheme. So it it doesn't have to all happen at once. So unless someone wants to make like a strong case for zero blob transactions now, I feel like we should ban them. And then the question is, you know, should we ban them just in the mempool or in the mempool and in protocol for now? Does it make life easier if, you know, we just assume they never happen versus we just assume they don't show up in the mempool?
I believe the zero blob transaction camp generally is assuming those two things happening simultaneously, especially due to the reorg considerations.
Okay, Andrew?
I think we should ban them in the protocol, and it's easier to start with some restricted functionality. And I agree with Peter that we should move in the direction of more generality, actually driven by concrete use cases rather than just some philosophizing. And also banning them both in the protocol and mempool makes things consistent and easier to reason about.
Okay, does that, yeah, that would be my assumption as well. And it's easier to relax that constraint in the future than to start without it and want to add it afterwards. Ansgar?
Yeah, just very briefly wanted to say, just because I think in general, I would have preferred to basically not ban them in the protocol. I think it's fine, but I think we can go ahead and ban them in the protocol for now. But just kind of philosophically, I would say that over time, at least, maybe now is not the time, but over time, we should be willing to move more and more towards a world of specialized mempools, where basically not having all the functionality offered at all times by the kind of inclined mempools would be fine. So for example, kind of at reorgs, not being able to reinsert some transactions into the mempools and whatnot, these kind of considerations. I know that client teams are kind of hesitant with that. I think philosophically, over the long term, we could move more towards being willing to have more specialized out of protocol mempools. But for now, I think just banning zero blob transactions everywhere, I think that's the pragmatic choice.
Okay. Does anyone disagree with banning zero blob transactions across the entire protocol, so both on chain and in the mempool?
Perhaps one note that's kind of for the banning is that I do agree again that it would be an elegant world to say that, well, if you use some weird combination of a transaction, then your transactions will not get re-included and you have to go through whatever route you went through the first time to get it re-included. But I think that kind of that sets a strange precedent, at least for me, that essentially the only way to include such a transaction is to go through some mining pool or some Flashbots bundling service. And essentially the only way to re-add it is to monitor the chain and then go through the same bundling service once more. And it kind of gets into this weird place where people will just not use normal clients. Everybody will use the bundling service because it can bundle stuff that the normal client cannot or will not. So I'm not sure that it's a path that's very, very healthy for the network to go down with. I mean, even nowadays, you can see that people are using all these forks of Get, and I'm assuming other clients do, just because you can get some MEV funds, I mean, MEV bonuses for mining. And I think it would just, every single opportunity where they can make more money, they will just, more and more people will switch over. And I mean, that's kind of fine if you have a good enough and fair enough infrastructure built out, but I don't think we have it yet. So I don't think we should push too many people towards that path. Well, basically every validator having to run Flashbots, because otherwise it's just not worth it.
Right, and I guess by banning them at the protocol level today, we keep this a bit more fair with regards to like the public mempool, where you just don't get this functionality by rallying around Geth or Nethermind.
I think it's more of a generic note that
right.
So what I wanted to say is that this reasoning that there will always be some operator which will be able to re-include something that clients cannot is a dangerous line of thought. It's So that's the only thing that I would like us to keep this in mind too, that for sure we can outsource certain functionality to other actors in the system, but we need to think it over carefully as to what the implications will be.
Yeah, I think that makes sense. Okay, anything else on the zero blob transactions? If not, then I guess in terms of next steps, could one of the 4844 authors just make the change to the EIP to say that basically type 5 transactions need a blob? Okay, Ansgar says he'll do it in the chat, so thank you. And then obviously the sort of ripple effect of that is like as we're continuing like implementing these transaction pool designs, we can now take for granted that blob transactions or type 5 transactions will come with a blob and separate those from the rest of transactions. Yeah. Okay, and I guess on a similar note, it might be worth going into the broader SSD conversation. So we had a call about this. I think it was literally yesterday. Ethan, do you maybe want to give a quick recap of the SSD call?
Sure. So we still have, first of all, this is not about the Blob SSD transaction and also not about the zero Blob transaction. Yesterday's call was for the representation of transactions as part of the transactions route in the block header. So there are two approaches there. One is based on using a union, that is using the transaction type to create separate objects underneath, depending on the type. The other one is the superset approach, where we use the same structure as you have on JSON RPC, where you essentially have a generalized transaction that can be used to represent all of the transaction types. And yesterday, we could not really decide which one is better. Both of them have advantages and disadvantages. So we decided that we simply create a couple prototypes so that we can actually see in praxis on concrete examples how big are the differences between them when they are actually used. Like, is a union really that ugly to implement in a zero knowledge circuit? Stuff like that. So I will be working on creating those prototypes and benchmarking them against each other to be included in about 2 weeks. So then we will take another session to decide whether we want to use the union approach or the normalized transaction approach to represent those on transactions route. There was also a discussion about Dev P2P networking, whether we want to upgrade those as well, so that when historic blocks are downloaded, whether this should use the original encoding based on RLP, or whether this should use the union or normalized transaction. That was also an open discussion point, but still undecided as well. Yeah, that's a summary from yesterday.
Thank you. Any questions, comments?
I have like a timeline question. Is this being considered in Cancun, right? Because it makes sense to be considered in Cancun because we are already adding SSD transactions, so we can like have a full move to SSD. On the other hand, if it will be considered in Cancun, it will definitely take longer time, right? So.
Yes, the idea was to including it into Cancun, and also to, if it makes sense, to align the common parts of 4844 with it. But the complex parts, like adding the SSC support to the ELs, is already done as part of 4844. So regardless of whether this is a union type or a normalized type that will go into the transactions route, it is the same complexity. I mean, right now we are just having RLP there. That also works fine. Yeah. And about Dankrod's question, to benchmark, there are things like when you get a proof based on this tree, how expensive is it to run a verification of a proof in a smart contract, for example? How big is the call data? How expensive is it to deploy such a contract? Mainly focused on consumers of the proofs, exactly.
So it's about gas cost of verifying like proofs on a union field or an optional field?
Of the union transaction or the normalized transaction, essentially, and also about the different network encodings, just a byte length for those.
Right.
Yeah. So yeah, we have the breakout for this 2 weeks from now, and we're using the typed transaction channel to chat about it in the meantime. I think also on the question of like Cancun, it would be good to consider this alongside like all the other potential things we can do for Cancun. So we haven't quite like made a call for people to come and shell their various proposals for the upgrade yet. So I think we probably want to do something like that, just so that we have sort of a full picture of what what we're trading off against. So I suspect in the next couple calls, it probably makes sense to try and get a list of like what are the things people would like to see in Cancun, and then this will be one of those items. But yeah, at least we'll have a full picture for making that decision. And if people, I guess, for people listening, if you already want to start sort of signaling what you'd like included in Cancun, there's a tag on ETH Magicians, Cancun candidate. So if you have your EIP there, you can just add the tag. And then there's also like a thread about the entire upgrade. For folks, even like if client teams, you have already strong preferences of stuff you'd like to see, it makes sense to just share those there, and we can start discussing that in the next couple calls. Any other questions about SSE transaction types? There's a comment about Ethereum Magicians being down. It's not down for me. That's weird. We can look into that offline. Okay, next up, I believe Ethan and Mikhail, you had another SSE related topic. So basically moving the withdrawal route from the MPT commitment to SSZ. Do either of you want to give a quick overview of this?
I can do that as well. So
thank you.
That's mainly the follow-up from what we discussed for Shanghai, and also postponed explicitly so that we can make sure that these withdrawals will follow a similar scheme that we have for transactions and receipts. But conceptually, the withdrawals are separate. So it could be that we want, for example, the withdrawals and the deposits from another EIP to be included earlier than the transactions and receipts. So that's why I'm bringing them up separately. And the other thing that I noticed when I wrote the EIP is that the dev P2P specs for how withdrawals are exchanged, I couldn't find them. So maybe that spec is still missing, or I didn't check at the correct place. But I wasn't sure if right now with Shanghai we are exchanging withdrawals in RLP or in SSE format on the wire. And if it's RLP, I'm not sure if it has a version byte in it. Yes, it's in the bodies and in the block header. There is also a root.
Okay. Any thoughts, comments on this?
We exchange withdrawals as RLP in block bodies in EL peer-to-peer.
Okay, so just a list, no version byte or anything.
No version there.
Okay. Is there a problem when we later transition to SSC, or can we like just bump the ETH protocol version, for example, ETH 69, and then use SSC And if it's like ETH68, then it's RLP, or how should this work?
Well, I guess it has to be, doesn't strictly have to be, but and it's nice if it's consistent with transactions. And currently, for block bodies, we use RLP for both transactions and withdrawals. So I would actually, if we are changing that, then we should change that, like the marshalling for transactions as well.
Yeah, for transaction, it's a mix. It's RLP for everything but type 5. And if it's type 5, it's SSC actually.
Right.
But yeah, that's for the other question, whether this should be bundled or whether we should transition withdrawals earlier. There is one thing to gain with withdrawals, namely that right now there is no single client that depends on this RLP based Merkle-Patricia trie route in the header. And the longer we wait, the higher it may become probable that someone is actually starting to use that route. For example, Rocket Pool could use it for some rewards computation or something. So not sure if that is a point that we should also consider. Not sure.
And I guess what's the best place to continue this conversation? The ETH Magicians thread, or is there a channel in the Discord as well?
Magician's thread exists. I think that one is all right. I'm not sure about a channel.
Okay, so let's use that, and hopefully people can review it in the next couple of weeks, so that yeah, we basically can make a call on this as we're looking for other Cancun stuff. Anything else? Okay. Next up, so there was a comment about the minimal presets, which I believe are like the testnet configs for the consensus layer, and that with 4844 and the introduction of blobs, this becomes part of the engine API, and therefore EL clients should be aware of it. Does anyone want to give the context on here for a second?
Yeah.
Oh.
Sorry. Yeah.
Yeah.
So first, I will just sort of introduce very briefly. The idea of the minimal config is, yeah, broadly it's meant to be used is for test nets. Also, the consensus spec tests use them for various things where it would be infeasible or just slow to run a certain set of tests in mainnet presets. Functionally, they change a couple of things. They change well, many things. One of which I'll mention, but the key thing for there is they use 6-second slots and 8-slot epochs, and then there's some other things. But you end up with 48-second epochs, and it's quite a bit faster. So, but the relevant thing here, for the most part, these have not affected the execution layer. And through Capella and Shanghai, that remains, as far as I can tell, true. However, in Cancun, that will start changing because with the blobs, there is now this blobs bundle v1 structure, which in the engine API is currently specified is hard-coded to so the number of field elements is 4,096. This is consistent with the mainnet preset, but not the minimal preset, which means that a minimal mode CL attempting to use the engine API will be just speaking an incompatible engine API protocol when it tries to use the engine get blobs bundle v1 call. V1 call. Now, this is on the one hand, you could say, well, this is a specific call, a specific data structure. But I think it's worth bringing up here because I think it's the first time, as far as I can tell, that the idea of this minimal mainnet preset has kind of encroached on the engine API, on the ELs. And so the question is kind of at some level what to do about it. One, and so I'm going to present, I mean, obviously part of presenting it here is I want, so if other people have options, that's great, but like some options to start with. One is we can just decide that, well, it is indeed just for testing. I'll present 4 options to start with that are meant to be sufficiently, let's say, a reasonable granularity. You can subdivide or combine them as desired. One is like, so basically we decide that, well, the engine API is only for mainnet. Like that's, and if the consensus back tests want to do some minimal thing, but they don't actually use the engine API because they don't do any networking things, then that's fine. We allow that to break, and anybody running an actual network now runs mainnet regardless. I would say one downside of, and that has obvious upsides of, there's no changes required at some level of the engine API. And so the status quo continues working. The downside is it effectively starts deprecating the minimal preset for anything but pure consensus backtests. And they become even more this artificial kind of thing that can't be used in practice. So that's due to a number of considerations which actually Capella exacerbates. So that's option 1. Option 2, you can have the EL somehow configured at startup, because there's nothing fundamental about this number. I mean, it's specified in the engine API, but you can just say, well, the engine API specifies some kind of preset. And you can, the next most general, and I'm ordering these in increased generality, or least specific approach is to say the engine set says, the ELs are given some configuration parameter that's basically very specifically this number of field elements. And either it's a Boolean or it's an integer or something, and then you can just make that compatible with the CL. That's option 2. Option 3 is there's an attempt to align things more broadly with the sort of idea of minimal and mainnet preset. So don't specify this particular field number of field elements. Say that, oh, well, the EL now knows about this notion of a preset, a minimal or mainnet preset. So this is a little bit more elegant for what it is, but at the same time, like it's something that ELs haven't had to care about, and it's kind of strange in some ways that they should have to. And the fourth is a much more general purpose thing and people have, at some level, the argument here is this call already starts existing. People have proposed it for Capella, an engine API call that will sort of do a kind of a configuration exchange, essentially, not the merge one, where it was just are we ready for merge, but just a more general purpose, what methods are supported and things like this. So those are some four sort of example options, and doing nothing is also a choice. So that's what I wanted to bring up.
Thank you. Yeah, Mikhail, you already have your hand up?
Yeah, I feel like the last option where the configuration is exchanged in runtime can, create an additional complexity of changing these parameters at the runtime. So basically one CL, theoretically can connect to EL and set one number for this particular config parameter. Then the other connects to it, and EL in general case have to support, switching it over to a lower number or whatever. So that's definitely a complexity on the engineering side. Having this as the command line parameter, I don't know, or passing full specification of the CL, chain to EL probably doesn't make sense, because EL really has nothing to do with most of those parameters. And I would say that this particular case is rather an exception than the common thing that we will see in the future, because here we have Blob transactions on EL side, which then included and propagated on CL side. So that's kind of like really looks like an exceptional case for me. So if we are about to do anything with that, as you've said, there is an option to do nothing. I would choose less invasive and less engineering complex solution as possible. So yeah, that's kind of like my initial opinion on that. And also I have a question: what kind of devnets or testnets are we running with a minimal preset? As far as I know, we have all of the devnets that we have for I know for Shanghai and for Merge and for other probably upgrades. They are running with the mainnet preset. Correct me if I'm wrong. So kind of like minimal presets more sounds like for the local machine setup or a small devnet that's having your testing you some features and all this kind of stuff. And probably it's not that bad to have field elements set to like a mainnet number in that always. I don't know. So that's kind of like my initial opinion on that.
Yeah, I would probably agree. I'll say that certainly once we get to yeah, I see Barnabas has indeed what Barnabas said. But it is true that by the time we get to certainly anything publicly visible, the public testnets are all mainnet configs. I will just speak with Nimbus. I mean, I just like anecdotally runs CIs often with minimal, just its presets as well as mainnet. But the other, maybe what I'll say is this: the other aspect, and another option actually is to change this particular field. And I think you mentioned this as well, or this is one of the things you say. But and to kind of pull this out, maybe least invasive / fixes the issue in a lot of ways. Have the minimal presets just say that this particular parameter is the mainnet parameter, so that we ensure that the engine API at least is not affected. This affects minimal presets to some extent. Yes, it makes them a little less minimal, but it also means that this issue just goes away. Another thing this has come up, and I don't think Hive uses it, and this is different than what Barnabas mentioned, but like you mentioned Hive, and Hive is certainly looking to run, for example, 6-second slots when they can. Now, there are different ways of doing this. One of them is you can take a tweaked mainnet preset and just change seconds per slot to 6, and that does work. But we also have a pre-existing preset, which is tested, that we have consensus spec tests and everything for it, that is designed exactly to run quickly. And so Hive has found this idea useful as well. So I think there's some utility in the minimal presets enough to not to want to get rid of them.
Oh, and yeah, Gijinder has a comment in the chat about the KZG libraries have hard-coded values for mainnet. I guess from this EL teams, does anyone have a strong opinion about this?
For Besu, it's actually a little less work for us to only support the 4096.
Anyone else? And there's oh yeah, Alexei, please.
Sorry. Yeah, never mind. I used to think that it is a fixed number, and we will probably change only block count possible in a block. So no settings for that, and the CKZG library does not support it. So.
Right. Yeah. I don't know. Maybe Dankrad or Proto. Is that a correct assumption that like will only ever grow the number of blobs per block, but the 4096 field elements per blob will stay constant?
Yes, that's pretty accurate.
I would not. That's. I mean, what do you mean, like forever? I don't
say 2 years. 2 years is my forever.
Right, right.
In this case.
I mean, I would not want to make this commitment. I mean, it's certainly like an option to long term also grow the blob size. I mean, that's why we're doing 4 different versions of the ceremony so that we can increase the blob size.
Okay. Okay, so I guess, and there's some comments on the chats now about just saying we can change the minimal preset value of just this for now. There seems to be agreement on that. So does anyone disagree for this specific preset value to just use the same as for mainnet?
I mean, I'd be okay with that personally.
Okay. Great. So let's do that. If someone can do a PR on the CL specs to update this, that'd be great.
Okay, I'll make that PR.
Awesome. Thank you. Okay. Next up, there was a discussion around standardizing the transaction pool namespace. Wesley, are you on the call? Yes.
Yeah, I'm here.
Hey, yes, do you want to give some context about that?
Sure, yeah. I drafted a proposal for standardized TX pool API for execution clients. Already spoke to some folks at each of the client teams, as most already have some endpoints and custom implementation for it, but proposal is a way to hopefully find an agreement on a more common subset, which would be great for interoperability, obviously, but also allows hopefully for more reliable integrations, for example, CR or inclusion lists that are being discussed at MEV Boost, for example. Not too familiar with how this process works or how to best approach it, but I think you shared a link already in the chat. It's also in the agenda from today's calls.
Yeah, I guess, has any EL client dev looked at this and have any opinions they want to share? Yeah, Marek?
I like all standardization efforts. However, I'm wondering if it is worth to change method names. Probably people got used to previous methods names, and we could potentially break lots of tooling because of renaming.
Yeah, the rationale for changing it was actually for backward compatibility, because each client currently has their own implementation. Changing that would more likely change existing integrations, but just setting up something new would at least avoid those issues.
Can we do something like just deprecating we can like mark the old names as deprecated, have the clients alias, both behind the scenes, and then eventually just remove the old ones from the spec? And I think there is precedent. I think there were some JSON RPC calls we did mark as deprecated in the past. I'm not quite sure which ones, but I remember having this conversation a while back. I guess probably in terms of next steps, if client teams just want to review that PR and leave any comments or leave like a thumbs up on it, that would be great. And then, maybe we make this change just to deprecate the old APIs or mark them as deprecated in the spec. Yeah. Does that make sense to people? Any objections or other thoughts? Okay, so yeah, let's do that. Anything else, Wesley?
No, that was it.
Cool, thank you. And then, okay, so that's what we had already on the agenda, but Jared, you said you wanted to chat about self-destruct.
Yeah, hi, can you hear me?
Yes.
Great. Hey, so we had I guess where I left off on self-destruct was a last piece of analysis around the potential impact of EIP 4758, which was the approach to just turn self-destruct into send all, and kind of the nuclear option, if you will, that would potentially, well, not even potentially, that would have backwards compatibility or would cause contracts to break. And since then, it kind of seems like there hasn't really been a proposal that's come forward that has seemed, or to me at least, seemed actionable to pursue. So I think that what I'm wondering to get a read on from people in this call is whether we think it would be valuable to put more resources towards analyzing contracts that would be broken with for EIP 4758, under the understanding that we probably won't be able to find every broken contract, but uncovering more could be valuable. I'm just not sure if we have decided that 4758 is completely untenable and to not pursue it, or it just is not very clear what direction to take here. So I just wanted to get a read from the community here, if anybody has any opinions.
Yeah, thanks. Andrew has his hand up.
Yeah, I think there was another development. There is this EIP 6048 proposed by EXIC, which might be less backwards, not as much backwards breaking. So it's more backwards compatible than the nuclear option 4758. So I don't know the details, but I think we should contrast the two and have a deeper look in. We haven't exhausted all the design options yet.
Right. So I've posted the EIP. It's 6046. I've posted it in the chat, and the idea was that when you self-destruct a contract, you just change the nonce to basically the upper, like the max nonce value. We don't delete the storage keys. We transfer out the funds, which is basically like send all. And then there was this, I guess the biggest addition was that you would modify create two. You would modify create two so that you can actually redeploy a self-destructed contract, but at the same address with different code. But basically, the check you do there is checking that the nonce is equal to this like max nonce value. So yeah, I guess, and there's a couple comments in the chats about like we do have to disable self-destruct. And we've sort of announced as part of Shanghai we're going to do it. So I don't know if people have thoughts about this 6046 approach, or otherwise we could maybe discuss that in more detail on the next call.
Yeah, it's been a bit since I looked at 6046, but I wrote in the chat that at least as I recall last I read, there were some concerns around by not removing storage slots, you're creating avenues for malicious behavior. And I think the example cited in the thread was Gnosis safe. But yeah, I'll have to look back into that to remind myself.
Right, and this is different than self-destruct now, which clears all the storage. So it's like you're resetting new code with the old data, and yeah, that could break
Yeah.
things. Any other thoughts? And I guess, yeah, and back to maybe Jared's original question, is it worthwhile to try and like do a extremely thorough analysis of all the contracts that would break on chain with like the 4758 proposal, given we already know there are, several that would break and they're, not trivial. It's not like two random contracts with less than one ETH. It is, there's a fair amount of contracts that would stop working. I'm not sure what the exact number is, but it's more than just a handful. Okay, so I guess not a ton of demand for the more thorough analysis. So maybe yeah, if in the next like few weeks, client teams can look at 6046 or potentially think about different ways to approach it, we can continue the conversation in the next call or two. But yeah, I think it's finding what's the least worst option. Okay. Anything else anyone wanted to bring up? Okay. Well, shall we?
Hello.
Yeah.
Just want to comment on the
the
change.
Yes, please. Yeah.
So I think we've discussed it in the 444 breakout before. The reason why we have this preset is because the PySpec and Python implementation is very slow compared to the production clients. So yeah, so we have, for example, we have a basic polynomial condiment proof generation and verification test, and it took like less than 1 minute with minimal preset, but it takes like 28 seconds to run this test case. So that was why I really want to keep the minimal preset. And
Right. Yeah, so it's like a 30x difference. I don't know. Does anyone have thoughts about?
Is this 28 seconds just for one test case, or there are like 100 test cases?
So it's only for this test case, but it's the PyTest run. So the test generator will be faster than this, but still we currently we use the minimal preset in our CI, so it will take this 28 seconds in the CI.
Minutes, right? Minutes, not seconds.
No, I think it's seconds. So it goes from less than 1 second to 30 seconds. Yeah.
Yes, and that's only one test case. One blob. One block.
To be honest, 30 seconds running once. I mean, like, even if it's run on CI, 30 seconds doesn't sound terrible. I don't know. If we have like 100 test cases, which, and multiple n times 30, if we are jumping from minimal to mainnet preset, yeah, that's something to worry about. But 30 seconds, I don't know.
Yeah, to be fair, we don't have many test cases. I think probably less than 10 test cases take the for proof generation and the verification. But I do expect that we will add more test cases after the iterations and yeah.
Okay, so I guess given the small number of tests, should we just keep it this way, or do we want to discuss this more, maybe async or on the consensus specs on the CL call, or I'm not quite sure. Yeah, what's the best approach?
I mean, I'm happy to discuss it in general elsewhere. I guess what I'll note without trying to get into too, I mean, sort of respecting this of the execution, like that just in general, the fact that this occurred, how much, I guess for one question would be for how much of this is an artifact for a particularly slow KZG implementation in the test runners, and how much is it really intrinsic to KZG? That is to say, how much is it fixable on a purely engineering side as opposed to a spec thing?
This is purely due to a slow implementation. Like this is because PyECC is like 100 times slower than like efficient implementations.
Right. I think this is an ugly enough problem to shunt into, because it would immediately become both an engine and execution layer problem, or immediately, you know, and during testing. If it's a question of this can be optimized in some way on the test runner side, that seems like a better overall investment for the ecosystem.
I think that we should start from setting the minimal to mainnet value as discussed before and see if it becomes really annoying, then reiterate on that and think again. Probably we'll see some opposition in the PR.
Okay, yeah, I think that makes sense. We can just, yeah, we can just make the PR for it and continue the discussion there. Oh, and Dustin already has a PR, amazing. Great. Anything else to cover before we wrap up? Okay, well, thanks everyone. And yeah, talk to you all soon.
Thank you. Bye-bye.
Thank you.
Thanks, everyone.
Yeah.
Bye
Thanks,
bye.
Tom.
Thank you.
Bye.
you.